Welcome back. In this lesson, we're going to understand what is meant by sensors and the purpose of various different types of sensors. Now, on screen, you can see an extensive list of sensors that you need to be aware of, and you should be able to understand what they do and how they can be applied. Now, most of the time, these sensors are used in control and monitoring applications. So these are normally input devices. You need to identify the type of data that's captured by each sensor and understand when each sensor would be used, including selecting the most suitable sensor for a given context. In the exam, you might be given a context where you're given a greenhouse or a lift or an autonomous car or perhaps even a camera, and you need to identify the sensor and the type of data it captures. So let's begin by looking at sensors themselves. Sensors are input devices which read or measure physical properties from their surroundings, so they read analog data. Examples include temperature, pressure, acidity level, length. There are many others out there. For example, you can measure light, you can measure proximity, and so on. Now, real data is analog, which basically means physical in nature. This means it's constantly changing. There is no one fixed, discrete value. And this can cause confusion for a computer system because it understands if a value is 100 or a 0, but it doesn't understand that it can be 100, 99, 98, back to 100 again. So it constantly changes and that confuses it. So there's a need for a device which converts physical values into discrete digital values. And this is usually achieved by an analog to digital converter or an ADC. That takes in analog data, which constantly varies, and converts it into digital data, which is ones and zeros. So sensors always need an ADC to convert the physical input data into discrete digital data. Now, when a computer is used to control devices such as a motor or a valve, it is necessary to use a digital to analog converter there because it's the opposite of a sensor. So when we were looking at output devices such as actuators, which were used in control applications, the computer or the CPU would send a digital signal, but the motor might not understand that because it deals with analog current. So there needs to be a digital to analog converter on the other side. And once this output is created by the actuator, it then influences the environment. So the sensor measures new data, which then needs to be converted into digital data, and the cycle continues. So sensors and actuators go hand in hand, along with analog to digital conversion on one end and digital to analog conversion on the other end. This process is known as feedback. So make sure that you understand what feedback is. It's when the output from the microprocessor will impact the next input that is read by the sensor. Another thing of vital importance is to realize that sensors send out constant values. They don't suddenly send a reading when the parameter they're measuring changes. They don't make any decisions. Students lose mark by saying sensors make decisions. They really don't. All they do is detect data and send it off to a CPU to make a decision. It is the microprocessor or the CPU that analyzes the incoming data and then takes some action based on it. So it makes a decision. So make sure that you are very clear. Sensors only detect data and pass it on to the CPU. It might need to be converted using an analog to digital converter, and the microprocessor is the bit that makes the decision. Okay, let's leave it at that and let's look at the types of sensors and their example applications. You might want to just simply pause the video at this particular point in time and go through this because there's a lot of sensors that are going to come up in the next couple of screens and you need to be aware of all of them. Okay, let's start with the temperature sensor. It measures temperatures of the surroundings by sending signals, and these signals will change as the temperature changes. And we use them for controlling things like central heating systems, air conditioning systems, perhaps controlling or monitoring a chemical process, perhaps controlling and monitoring the temperature in a greenhouse. Another sensor is moisture sensor. This measures water levels in, for example, soil. It is based on electrical resistance of that sample that's being measured because obviously water conducts electricity. And it's used again in greenhouses and perhaps in a food processing factory. Humidity sensors are used to measure moisture as well, but this time it's in the air. So you look at the conductivity of air here, and this is used to monitor humidity levels in a building or a factory, maybe even manufacturing of microchips, and even controlling humidity levels in the air in a greenhouse. Light sensor uses photoelectric cells that produce an output. And again, this depends on the brightness level. So it detects the brightness level and based on that, it produces an output. So what do we use it for? We use it for switching street lights on and off. We use it for switching car headlights automatically when it gets dark, things like that. An active infrared sensor uses an invisible beam of infrared radiation, which is picked up by a detector. So if this beam is broken, then there will be a change in the amount of radiation reaching the sensor or the detector. This is used to turn on car windscreen wipers automatically when it detects rain on the windscreen. Security alarm systems, for example, when an intruder breaks a beam, that's also possible. Passive infrared sensors are used to measure heat radiation given off by an object. For example, the temperature of an intruder or the temperature in the fridge. We use passive infrared sensors. Security alarm systems are based on detecting body heat, monitoring the temperature inside an industrial freezer or a fridge. All of those are possible applications. Pressure sensors have a transducer that generates different electric currents depending on the pressure applied. And we use it to measure the weight of lorries or vehicles. We measure the gas pressure in a nuclear reactor. Even if you wanted to measure how many cars are crossing a road, a pressure sensor would probably be used there. Other types of sensors include sound sensors. These are basically microphones that convert detected sound into electrical signals or pulses, and we use it to pick up noises of footsteps or alarm systems, and we use it to detect if there's leaks happening, things like detect the sound of liquids dripping at a faulty pipe joint, for example. Sound sensors or acoustic sensors are used there. Gas sensors are most common in factories, and they're normally used for oxygen or CO2 or carbon monoxide or various different types of gases, and they monitor pollution levels in the air. They can monitor oxygen and carbon dioxide levels in a greenhouse, and also oxygen levels that are being emitted in a car exhaust, which tells you how much pollution a car causes. pH sensors measure acidity through changes in voltages, and they are used to control acidity levels in the soil or a chemical process. Magnetic field sensors measure the change in magnetic fields, and they are used in mobile phones and CD players or even anti-lock braking systems in cars. Accelerometers are sensors that measure the acceleration and motion of an application. They normally use piezoelectric cells, and their output varies when the velocity changes. And they're normally used in mobile phones, in cars, all sorts of things. When you tilt your phone and it goes from portrait to landscape, that's basically an accelerometer in action. Proximity sensors detect the presence of a nearby object. They detect when a face is closer to a mobile phone. So when you bring your phone closer to your face, when you want to make a call, the screen switches off. Flow rate measures the flow rate of a moving liquid or gas, and then they produce an output based on the amount of liquid or gas that's passing over the sensor. These are normally used in breathing devices and inhalers in hospitals, or perhaps measuring the gas flows in pipes in factories and so on. And finally, we have the level sensor. These sensors use ultrasonics, and they're used to detect the changing liquid levels, for example, in a tank, or perhaps the level of water in a river, and they do that through using capacitance or conductivity. Remember, level sensors can also be optical or mechanical in nature, and their applications include monitoring the level of petrol in a car, or perhaps in a pharmaceutical process where the powder levels in a tablet production needs to be monitored, or for detecting leaks in air conditioning when we have refrigerant which keeps everything cool, and that can also apply to fridges as well. Okay, that's enough about sensors. You might want to take a bit of a break there. If you haven't made your notes on these sensors, these are the important sensors. You need to be aware how they generally function. You don't need to go into any more depth than that. And most of these sensors are going to be pretty straightforward because the name generally tells you what it does. Okay, so what's the difference between monitoring and control? We've heard these two terms earlier on. The difference between monitoring and control is that monitoring just observes what's happening in the environment and reports back. Control actually affects the environment and makes a change, which then gets monitored again, and then it influences the environment again. So the processes are generally similar, but the end, the output, is where things change slightly. Now, examples of monitoring are that you're monitoring the health of a patient in a hospital, you measure their vital signs, or you monitor for intruders, or you check the temperature levels in a car engine, or you monitor the pollution levels in a river. You're not actually changing anything there. You're just simply reporting back whatever you're observing. Examples of control could be turning street lights on or off, controlling the temperature in a central heating or air conditioning system, which automatically influences how much hot or cold air is blown out. Chemical processes, which need to maintain the temperature or the pH level in a factory process exactly, otherwise, it will influence the product. Operating anti lock brakes on a car when necessary, controlling the environment in a greenhouse. Now, all of these are examples of control system. So what actually happens? Well, sensors send signals to the microprocessor. They detect whatever's happening and they pass it on. The signals are converted to digital if needed using an analog to digital converter. The computer's CPU or microprocessor analyzes the data that's received and it checks against some stored values. And for a monitoring system, if the new data is outside the acceptable range, normally a warning message is sent to the screen or an alarm is activated. The CPU or the microprocessor has no effect on what is monitored, it's simply watching the process, and then the loop continues. However, if this was a control system, The new data, if that's outside the acceptable range, the computer or the microprocessor will then send signals to valves or motors to make a change in the environment. And the output from the system affects the next set of inputs from the sensors, and this creates a feedback loop. So the sensors measure this new data, microprocessor makes a new decision, actuators influence the environment, and the cycle continues until it's stopped. So they're kind of like similar in the initial stages, but the output stage is different. Now, keeping that in mind, you need to be aware on what happens in common monitoring and control systems such as security. So on screen, you see a diagram. You've got an interface which has a few sensors. There's a computer microprocessor. There are siren and lights. The security monitoring system will carry out the following actions. So the system is activated by a password on a keypad. The infrared sensor will pick up the movement once it's active of an intruder in the building, or the sound sensor or acoustic sensor will pick up sounds. Perhaps the pressure sensor will pick up the weight of an intruder coming through the door or a window. The sensor data is passed through an ADC and is converted to a digital value. The microprocessor will sample the value, and then there will be probably a time frame, maybe every 5 seconds, 10 seconds, whatever. The data is compared with the stored values, and if the incoming data values are outside the range, the computer sends a signal to a siren to sound the alarm or turn the lights on or off or make them flash. In this process, a digital to analog converter is used because the CPU sends digital values, but the siren and the lights will only understand analog values. The alarm then continues on, the lights continue to flash until they are turned off by a user who needs to enter a password. Now that's basically how a typical monitoring system works. And that same rule applies to a hospital-based monitoring system where the interface might have different sensors like temperature, heart rate, breathing sensors, and then you might have a screen or an alarm instead of a siren and lights. And the process is exactly the same. Sensors measure, data is converted into digital data using an ADC. Sampling is happening every 5 or 10 seconds or whatever the frequency is. The computer's CPU will compare it to stored values, and if they are outside the acceptable range, a signal will be sent via digital to analog converter to an alarm or a screen, and this monitoring continues until the sensors are disconnected from the patient. So the process is exactly the same as the previous one. For control systems, the process is similar, but the output part changes. So here we have a street light, or perhaps turning the lights in your home on or off automatically. The system is fitted with a light sensor which constantly sends data to the microprocessor. This needs to be converted to digital data using an ADC. The microprocessor samples the data on a frequency, maybe a few seconds, maybe every minute or so. It compares it to pre-stored values, and if the data is outside the range, the microprocessor now sends data to the actuator, and this needs to be converted using a digital to analog converter. If the data is less than the value stored in the memory, a signal is sent from the microprocessor to the street lamp or the lamp to turn it on. If it's greater than the value or perhaps equal to the value, then a signal is sent from the microprocessor to the street lamp to turn it off. And both these signals are converted using that digital to analog converter and then actioned upon by the lamp or the street light. And this process continues until it's turned off. Now, there might be a bit of a time delay there because you don't want to keep the lights turning on or off if there's clouds or something else is affecting the sensor. So you might have a 10, 20, 30-minute gap between the lamps being turned on or off. Those kind of things can be built into the programming. And the same type of approach is applied to anti-lock braking systems inside cars. Here the sensors change, so if one of the wheels of the car rotates too slowly or is locking up, a magnetic field sensor sends data to a microprocessor. The microprocessor then checks the rotation speeds of the other three wheels, and if they're different, for example, they're rotating faster, the microprocessor will send a signal to the braking system to reduce pressure to make sure all the wheels are spinning at the same speed. Now you can pause the video and you can go through the entire process of anti-lock braking system. That's not important. What's important is that you understand that sensors send data to a microprocessor, the microprocessor samples it, acts upon it by comparing it against pre-stored values, and then either influences an actuator or it doesn't. And this process continues. That is what you need to be talking about in the exam. And that same thing can apply to a central heating system. I won't go through this particular one. You can pause the video and study that, but it's going to be exactly the same. Sensors measure data, ADC is used to convert data, microprocessor acts upon that data, sends a signal to an actuator. That needs to be converted using a digital to analog converter. The actuator then influences the environment and the cycle continues. There is that feedback loop until it's turned off. Now do pause the video and go through each of these processes so you're aware of generally how these work. These are the common types of processes that you're asked about in the exam. You don't really need to know every single type of process that's out there as long as you know what the general process is. So do pause the video and study each of these processes, including the greenhouse, where there's a lot of sensors, up to 5 sensors that can influence the environment. And again, you don't really need to know every single one. The process is exactly going to be the same. So as long as you understand that pattern, sensors measure, ADC is used to convert it to digital data, microprocessor samples, it acts upon that data by comparing it to pre-stored values, sends a signal to the actuator, which is converted via a digital to analog converter, and the actuator then acts upon the environment, and the loop continues. So there's that feedback loop. As long as you understand that process, you can answer any type of monitoring or control question. And with that, we'll draw this lesson to a close. You should be able to answer the following questions. What is a sensor and what type of data does it measure? You should be able to list at least 5 different types of sensors and their uses. You should be able to explain the difference between control and monitoring systems, and you should be able to explain the use of control systems in greenhouses or lifts or whatever the exam board can throw at you, because the process is going to be exactly the same. Sensors measure, data is converted using an ADC, microprocessor compares it to pre-stored values and then acts upon the data if it's outside the range. If it's a monitoring system, an alarm or alert is raised. If it's a control system, then the signal is converted using a DAC and the actuator acts upon the environment, and there is a feedback loop because the sensor measures new data and the process continues until everything is turned off. That's all for this particular lesson. If you do have any questions, as usual, please get back to me. Otherwise, I'll see you in the next one.